Good day to viewers and evaluators. My name is Gui Liang Yu, and my project title will be An Internet of Things for Education in Competence System, supervised by Associate Professor IR Dr. Norhaliza Abdul Wahab. My project objectives are to develop a reliable and cheaper laboratory scale competence system, to develop a web-based interface to facilitate online experiment and projects for students who have time inflexibility such as during this pandemic, and last, to evaluate the performance, quality, and response time of the web application interface compared to real experiment. During this presentation, I'll be focusing on the first and the second objective, while the last will be during the seminars. Major part of my system will be a copper tank, water pump, and reservoir along with a main circuit behind the supporting wall. As for the web application or web GUI, we have title and description, data visualization, tuning tab, and function tab. To demonstrate the functionality of the prototype, the web GUI is displayed along with the camera footage of the system at the right-hand corner. We will begin the demonstration shortly. The data visualization comprises of output and input parameters, while tuning parameters is in the tuning tab. We will start out with a random set of tuning parameters, for example, set point equals to 15, proportional gain equals to 20, integrate equals to 40, and finally derivative gain equals to 5. The settings are submitted and waiting for registration. When the tuning parameters are registered, the system is ready and the user can begin the experiment. I will proceed to turn on the power supply of the prototype. It is recommended to switch on the prototype before any experiment for system setup. Error reading is shown in the tanks and gauge, while pass reading in the line graph. The prototype has delivered its first reading and will wait for the second one before turning on the controller. Consecutive readings span for 15 seconds, which is limited by the database provider. After that, the controller will be switched on using the power button. The green power button indicates the controller is on and vice versa. For demonstration purpose, this section is sped up to show its behavior. The data acquisition is successful but limited by the sampling rate. Lower sampling rate will provide a more real-time experience to the user. After successful readings, the controller is turned off to get a depression in the response curve. Red power button, an indication of the off controller. Similar to the earlier section, this is also sped up. During test trials, the quality of data service influenced the effectiveness of data transmission. After the experiment, user can download all information in CSV format using the Download Data button. CSV format is chosen because it is compatible with Microsoft Excel and MATLAB environment, which are common in control system research. From left to right, we have date and time, output parameters, input parameters, and tuning parameters ready for documentation. After that, unwanted or rejected data can be deleted using the Clear Data button. The information are deleted permanently. It is encouraged to be mindful before clicking the button. Now the prototype is ready for a new project. In conclusion, the concept of an online experiment equipment is possible because the online user interface is able to make direct communication to the prototype while receiving its output. The performance of the system can be improved by using better components such as specialized microcontroller. This is the end of my video demonstration, and thank you for your time.